My name is Colleen O'Laughlin, and I am a postdoctoral fellow in Michael Fischbach's lab at UCSF. And Michael's lab is interested in understanding not only the bacteria that live inside of us and on us, that play a really important role in our health and our immune function and that type of thing, but then also, at the same time as who's there, we're really interested in understanding what molecules that these bacteria are making. I am one of 7 children who came from English teachers, and all of my siblings are either English teachers or literature majors or journalists. And so I was sort of always the black sheep in my family for not being a literature major. So in undergrad, I was a biochemistry and art double major when I first started out, and I ended up graduating early from Ithaca. I don't know, people were like, oh, that's a great break for your mind between science classes, and I was like, I don't know, it was always a lot of effort and a lot of thinking and measuring and redrawing and sort of trying something out, seeing how it worked, and then reassessing what didn't work, how to fix that in the future, and then how we're going about that. And I think that's what scientists do. Right now, I have a couple things that I've been dedicating a lot of mental energy to. So one of them is working on this skin bacterium, acnes, so P. acnes. That is a bacteria that all of us have on our skin. It's present at high rates and that type of thing. And it's commonly associated with acne lesions. And so what I'm focused on trying to understand is if there's a molecule that P. acnes makes that sort of helps keep it from turning pathogenic, or if there's a special molecule that P. acnes makes, and when it starts making that, it becomes a pathogenic bacteria, and so it causes these acne lesions and that type of thing. The bacteria that live in us and on us are not these sort of just free-riding bacteria that are just hanging out and not doing anything. They're actually really critical components to how our body works to defend itself against invading pathogens, sort of environmental onslaughts and that type of thing. And the idea is that the bacteria are making molecules that are dramatically altering host behavior. So how our immune system is responding to things, how are we breaking down our food. And so we're interested in understanding exactly what bacteria are there, and then what are the molecules that they're making, what are those molecules structurally, and then what are the molecules doing to us. And so sort of the P. acnes project is a very zoomed in specific one, right? About this idea of what molecules are present or absent in different healthy versus disease states. But really my dream would be to be able to do this for every body site in a healthy individual, and then also start building databases from people that are in various disease states to try to see all right, healthy people have this subset, and then there's this much overlap with a disease state. So what molecules are missing, and can we help use that to inform diagnosis and also treatment of these diseases? And so what I sort of envision being able to do is sort of using all the sequence data that's been generated by all of these other labs and the Human Microbiome Project. Can we take all of that information into one spot and define not a core microbiome, but a core set of molecules that are bacterially made that everyone has. That might give us a way to increase our ability to diagnose new diseases, to quickly figure out what molecules people are lacking. And in some cases, it could just be being able to resupply that molecule really helps people be much healthier and helps deal with the symptoms of these different diseases. You have to be incredibly creative to be a scientist, right? You're doing things that no one else has ever done before. No one's thought about, no one's tried to do. And so there is no recipe. There's no do X, Y, and Z protocol. You're building the protocol. And so you have to sort of be adventurous and creative and be I'm gonna try this and it's probably gonna fail. But that's okay, because I'm gonna learn things from that failure. And just when you're drawing, you put a line down and you're that's not the right line. And you look at it, figure out why, erase it, and retry it. And science is the same thing. You grow a bacteria, you try to do an experiment, and you're that didn't work. All right, let's change one thing and try it again so that we have an idea of what's going wrong, how do we move forward, and that type of thing. And what defines you as a scientist is getting back into the lab and picking your pipettes up and doing more experiments when all you want to do is go home and cry in bed and be I don't want to do this, that's when you sort of know you're a scientist, when the option of going home is less exciting than staying and maybe failing again. Because that next experiment could totally be the one that worked and like changes everything, right?